In this lesson, I will explain to you some mathematics operation using numpy. So we will discuss how to add the matrices, subtract, divide, multiplication. If you want to find out the index of some specific element in the matrix, I will show you in this lesson, as well as how to calculate the standard deviation, square root, log, natural log and base 10 log, etc. So first of all, keep in mind, do not forget to import numpy as np. So I'm going to execute it and it will execute successfully. Okay, now here see, I have made two arrays. The name I have given array 1, array 2, but again you can give any name according to your programming. So this is the syntax np dot array, and this is the 2D array. See, two square bracket are here and two are at the end. Then this is my first row of my matrix, second and third. Similarly, I have made the second array and I want to print both. When I will execute it, you will see this one is my first matrix and this is my second matrix. So same operation. See, here you have to write down three separate lists, right? So if you want to make the same matrix, we can use another syntax, that np dot arrange, which we have learned in our last lesson. And here in the parenthesis I wrote 1 to 10. So 10 is exclusive. It means with the help of arrange function we will get 1D array, and here I have used the reshape function. So reshape will convert into 2D or 3D. So here I am going to convert in 2D, but keep in mind that the product of these two, I said I need 3 rows and 3 columns. So 3 times 3 is equal to 9. We have, if I will run only this part, right, I will have 1D array from 1 to 9, and the product of these two should be equal to 9, otherwise it will not run. So when I am going to execute it, you will see the same output, right? Same output is here. If you want, you can write down like this. If you want, you can write down like this, right? But if you want some other numbers not on a sequence, then definitely you have to use this method to make your matrix. Okay, now suppose if you want to add two matrices, matrix 3 and 4, which is 3, this is 3 and this is 4. So the very simple way is write down the name of the variable plus array 3, array 4, and I'm going to execute it. So the output is 12, 14, 16. Now how the system adds, how the matrices works, if we want to add corresponding entries add together. This is the first entry of the first matrix. It will add to the first entry of the second matrix. So 11 plus 1, that is why it is 12. For 14, see the second, this is the second entry of the first matrix, this is the second entry of the second matrix, 12 plus 2, 14, and so on. How simple is it, right? But another method, if you want to add, if you want to use the numpy function, so numpy np dot add, and in parentheses you have to write down the name of your variables, but there is no need to put the plus sign, only comma if you want to use the add function. When I will run it, you will see the same output. Whatever we got from here, the same output is here, but a little bit difference in the syntax, right? Okay, now is, if you want to add, suppose this is my, I will show you, this is my matrix 3. If you want to add all the entries together, just like 1 plus 2 plus 3 plus 4 plus 6 plus 5 and so on, right, then you have to use the sum function. So you should be very careful. What is the difference between add and sum? Add will add two matrices together, but see here I will run first this array 3. So to show you, this is the output of array 3. Now I will remove this comment sign from here and I will run it. So you will see we will get the total of this matrix, which is 45, right? So sum function will add all the entries, but add will add two or three matrices together. Now here is np dot sum and array this one. If you want to sum each column, right, suppose you want to make this addition of this column, addition of this column, this column, then you have to put access is equal to 0, right? I will run and show you the output. So see 12, 15 and this. So how come I have this? From this is the total of array 3. This is our array 3, right? Access is equal to 0 means we are going to add the column. So here 1 plus 4 5, 5 plus 7 which is 12, 5 plus 2 7, 7 plus 8 15 and so on. If you want to add rows like this, you want to get the total of this row, then this row and this row, so everything is same. Instead of access is equal to 0, you have to put access is equal to 1, right? So when I will execute it, now you will see this is the total of each row. See, first is 16 15, so 1 plus 2 plus 3 6, and this is the total of 15 and this is the total of 14. So for column access is equal to 0, for rows access is equal to 1, right? But when we will work for the data frame, it will be opposite. I will let you know at that time that access you have to use access is equal to 0 and 1. Okay, now to subtract, same thing. Array 3, the very simple is array 3 minus array 4. When we will see our, this is the output. And here we have negative negative. Why? I will show you. Where is these two? See array 3 1. Again the subtraction will follow the same pattern, corresponding entries. This is the first entry of the first matrix. It will subtract the first entry of the second matrix. 1 minus 11 which is equal to minus 10, 2 minus 12 which is equal to minus 10. That is why we have all these minus 10 minus 10. But again it is not necessary that always you have to subtract array 3 minus array. If you want, you can write down array 4 first according to your programming. Now we have positive because it is negative. We were subtracting 3 minus 4. Now we are subtracting 4 minus 3. Okay, and if you want to use the numpy function, then same thing, np dot subtract, and write down in parentheses that you want to subtract these two, but there is no need to put the negative sign. Just execute it. See, you will get the same, this and this. Now it is your job, change the position, bring 4 here and 3 here, you will get this answer, right? So I hope the add, sum and subtraction is clear. Now for division, to divide the matrices, see, only you have to put this division sign, array 3 divided by array 4, and execute it. If you want, change the position, make this 4 and then this 3, the output will be different. But if you want to use the numpy function, np dot divide and then execute it, right? Okay, so now for the mean, if you want to calculate the mean of array 3, so only you have to use dot mean. Mean means average, do not use the word average. Okay, dot mean and execute it. So mean of array 3, all the entries you have to add, then divided by 9. Why? Because we have, I will show you where is this, this one, 1 plus 2 plus 3 plus 4 and so on. It is 45 divided by 9, so we will get 5. So the average is 5 if you want to use the numpy function. So np dot mean and in parentheses write down array 3, array 4, whatever you want. So execute it, answer is same 5, right? If you want the mean, access is equal to 1 of each row, access is equal to 1 means rows, so execute it. This is the mean of first row, this is the mean of second row, and this is the mean of third row. Similarly, if you want to get the mean of all the columns, so access is equal to 0, then execute it. 4 5 6, this is the mean of first column, second, and so on. So for median, same thing. To find the median is the center number, np dot median array 3, executed, median is also 5, right? If you want to calculate the median of all the rows, so access is equal to 1. For columns, access is equal to 0. So I hope the concept is going to be clear what I am saying, right? Now one of the most important thing is how to multiply the matrices. Keep in mind that when we add in matrices, when we add, when we subtract, or when we divide, it works. The corresponding entries, see, this is the fourth entry or the first entry of the second row. It should add or subtract or divide with this 14, first entry of the second row of the second column. But multiplication does not work like this in matrices. So if you want to multiply just like corresponding entries, you have to use this asterisk sign. I will show you execute it. So here the corresponding entries are multiplying each other, but in actual life this is the wrong answer of two matrices if you want to multiply, right? Again, if you want to use the numpy function np dot multiply, execute it, you will get the same answer. Yes, if you want to multiply the corresponding entries, you can use this asterisk sign or this syntax. But in actual life, if you want to get the correct answer how to multiply two matrices, so means you have to multiply a row with each columns, right? Then you have to use this add function or dot function. I will execute it. So this is the correct answer. For dot, same thing, this is the correct answer, because how we multiply, we multiply first row with first column, then this with this, then this with the third column, and so on, right? So multiplication is totally different in matrices. So if you want to multiply the corresponding entries, this method is fine. But if you want to get the correct answer, then you have to use add function or dot dot function. Okay, now move on to, I have made another variable array 5, and here I said np dot arrange 1 to 100. I want to make a matrix of 100 entries. That is why I wrote 101. So 101 is exclusive. And then reshape 10 by 10, right? So 10 rows and 10 columns, but see the product of this 10 multiplied by 10 is 100, and here I have 100 entries. When I will execute it, you will see a big matrix, right? Okay, now if I say what is the maximum number of this matrix, so you have to use dot max function, execute it, and see 100, and you can see here 100 is the maximum value. Now if you want to see what is the index number of this 100, so keep in mind the index start from 0. You cannot say 1 2 3 and so on. No, 0 1 2 3. So definitely the index of this 100 will be 99. So you have to use arg, right? Argmax will give you the index, which is 99. If you want to find out the minimum value, so the minimum value is 1 in this matrix, so execute it. So this is minimum value and 0, sorry, 1. So now if I will ask you what is the index of this minimum value, 0, right? Because now you know very well that indexes start with 0. So here same thing, array name dot argmin, and execute it, so it will give you the index of the minimum value, which is 0. Then to find the maximum value of each column, right? If you want to find out the maximum value of the whole matrix, then you do not have to specify access is equal to 0. But if you want that each column, so access is equal to 0, and execute it, so I will show you that this is the first column, and this is the maximum or the highest value. This is the second column, this is the highest value, and so on. So access is equal to 0 will give you the maximum value of each column, and to find the minimum value of each column, right? So only you have to use min here instead of max. Execute it. So 1 2 3, this is the minimum value of first column and second column and third column. Again I will show you, this is one column, minimum value is 1, this is the second column, minimum value is 2, and so on, right? Okay, now is to find the maximum value of each row wise. So execute it. So this is the maximum value of each row. Minimum value of each row, access is equal to 1. I know, I hope that now you are getting very well when you have to put access is equal to 1 and access is equal to 0 in numpy. So if you want to find out the square root, I'm going to remove this. I will again show you array 3. This is array 3, and if you want to find out the square root of each and every entry, right, say square root of 4 will be 2, square root of 9 is 3, square root of 8 will be 2 point something, right? So you will find out np.sqrt. Do not write down a square root complete, only sqrt executed. See here, this is instead of 4 we have 2, instead of 9 we have 3, and all these are the square root. If you want to use the numpy function, so np.sqrt, here I am using array 4, right, executed. So see, the output is different. Why? Because this is for array 3 and this is for array 4, and array 4 I already showed to you. Okay, to find the standard deviation, so np.std, do not write down complete standard deviation, this array 3, and then we have 2.58. What standard deviation gives us? With the help of a standard deviation we will find out how far our data values are from our mean. Okay, to find the exponent of each element e power x, so here first I will show you array 4. What is array 4? We have, this is array 4, right? If you want to find out the exponent, so np dot x and execute it. So these are the e power x value. Then to find out the natural log, n log means natural log, np.log, same array 4 and execute it. So you will see this is the natural log. And then to find the log base 10, only you have to write down log 10 here and execute it. So see, there is the difference between natural log and log base 10. So these functions we will use when we will work on machine learning. I hope this is clear. Please practice it. See you in the next lesson, and thank you.